Hello everyone, my name is Naveen and I'm a second year student in the Department of Artificial Intelligence and Data Science. Today I will be walking you through 10 Python programs that perform various statistical analysis on a weather dataset, particularly focusing on air pollution such as SO2, CO, and PM2.5. These programs include sampling, correlation analysis, covariance, hypothesis testing, and confidence intervals. And let's dive. The first one is calculating the population mean of SO2. In the first program, we calculate the population mean of SO2 from the dataset. We import necessary libraries, pandas for data handling, NumPy for numerical operations. The dataset is located using pd.read CSV. We select the SO2 column and calculate its mean using np.mean. Finally, we print the population mean. This gives us a baseline to understand the average level of SO2 in an entire dataset. And the second program is sample mean with n equal to 100. Next, we extract a random sample of 100 rows from a dataset and calculate the sample mean of SO2. We use df.sample n equal to 100, random, random state equal to 42 to ensure reproducibility. The mean of the SO2 column in a sample is calculated. Printing the sample mean shows how the smaller sample approximated the population mean. It demonstrates sampling variability. Sample means can differ slightly from the population mean. And the third program is about sample mean with n equal to 1000. Here we increase the sample size to 1000 to see the effect on the sample mean. Again, we use df.sample n equal to 1000, random state equal to 42. Calculating the sample mean of SO2 shows it is closer to the population mean compared to a smaller sample. This illustrates the law of large number, where larger sample tend to approximate the population parameters more accurately. And the fourth problem is Poisson correlation between SO2 and CO. A problem 4 explores the linear relationship between SO2 and CO using Poisson calculation. We calculate population means of SO2 and CO. Then we use stats.Poisson or column 1, column 2. To complete the Poisson correlation coefficient, the coefficient ranges from -1 and 1, indicating the strength and direction of a linear relationship. A positive value indicates that as SO2 increases, CO also tends to increase and vice versa. The next, the next one is Spearman correlation. Here we use Spearman correlation, which measures the monotonic relationship between SO2 and CO. Unlike Pearson's Spearman correlation uses ranks, so it can capture nonlinear trends. We use stats.Spearman correlation 1 and correlation 2 and print the coefficient. This is particularly useful if the data is not normally distributed for or contains outliers. And the next one is covariance matrix. Program 6 calculates the covariance matrix between SO2 and CO. Covariance measures how two variables vary together. Using np.cov of column 1, column 2, we got a 2 into 2 matrix showing the variance of each variable and their covariances. Positive covariances suggests that both variables increase together, while a negative value would indicate opposite trends. The next one is one sample Z test for PM.2.5. In program 7, we perform a one sample Z test to test if the mean PM2.5 is equal to hypothesized values. We calculate the sample mean, standard deviation, and sample size. Input the Z statistic using the formula. The p-value is calculated to access statistical significance. The small p-value indicates the observed mean is significantly different from the hypothesized value. The next one is confidence intervals for PM2.5. Next, we calculate confidence intervals at 90%, 95%, and 99% levels for PM2.5. The critical Z value is computed for each confidence level. Margin of error is calculated and the confidence interval is derived. Margin of error is calculated and the confidence level is derived. This shows the range in which the true population mean is likely to fall. Confidence intervals provide more insight than the single mean value, giving a measure of uncertainty. Program 9. Repeat confidence interval calculation. Program 9 is essentially a repeat of Program 8. It reinforces understanding and confirms results for PM 2.5 confidence intervals. Repeating computations ensures reliability and consistency of statistical results. The last program is simulation of confidence intervals. Finally, a program 10, we simulate 25 random samples of size 50 and calculate confidence intervals for each sample. Random sampling with replacement is performed using np.random.choice. For each sample, we calculate the sample mean, standard deviation, and 95% confidence level. All 25 intervals are plotted using matplotlib. This visualization demonstrates the variability of sample means and how confidence intervals can differ from sample to sample, even if drawn from the same population. These 10 programs demonstrate essential concepts in statistical, population versus sample, correlation, covariances, hypothesis testing, and confidence intervals. These analyses are fundamental in data science for understanding data distributions, relationships, and variability. I hope this walkthrough helps you grasp both the theory and practical implementation using Python. Thank you for watching. Mhm. Yeah, we don't. Wow. You were.